All your sense. Let's see this question of Pathfinder from Kinematics chapter. It's MCQ question number 19. Question states two balls A and B are simultaneously released on two frictionless inclined planes from the position shown. The inclined planes have equal inclinations. The balls pass through a particular horizontal level. 12 seconds and 4 seconds after they were released. Find how long after they were released will they be closest to each other. There are 4 options given. We have to tell which of the 4 options is correct. So let's try solving this question. So I want to find one result that will be useful in getting answer. Suppose I have a fixed incline and suppose the height of this incline is h. So the length of this incline s, this length will be simply s will be h cosec theta, and the particle is released from the top from rest, and I have to tell how much time will it take to reach the bottom. So down the incline it is a smooth surface, so acceleration would be simply a is equal to g sine theta. So if the time taken is t, so I can use the second equation from top to bottom, so that s is equal to, starting from rest, so s is equal to half at square. S is h cosec theta, a is g sine theta, so half g sine theta into time square, take cosec theta on that side. So this will become h is equal to half g sine square theta into t square. That is my equation 1. I'll be using this equation. Okay, now let me read this one part of the question again. The balls pass through a particular horizontal level 12 seconds and 4 seconds after they were released. How? Okay, so first this part. So the balls were released from here and here. After different times they reach a certain horizontal level. So come to this. Suppose these are two inclined. They have the same inclination theta. Ball 1 is released from here. Suppose the height of this ball from this point is say h naught. This is h naught, and the other ball is released from here at a different times, obviously, because their starting point is not same. So at a different time, different times they reach maybe on this horizontal level. So this ball comes up to here and it goes like this. This has to travel a shorter distance, so this time would be the smaller time, that was a 4 seconds. And this ball comes from here to the same level. So this ball reaches here and that takes a longer time, 12 seconds. And the incline is the same, angle is same, and suppose this height is say h, and I'll use this result. Starting from the same initial point, falling down a vertical distance h, time taken is t, so h is equal to half g sine square theta t square. So for this ball I can write the height fallen is h naught plus h, so h naught plus h is equal to half g sine square theta into time square, which is 12 square. Second equation. And for this ball, again starting from the rest, height fallen is h, time taken is 4 seconds, same incline, so h is equal to half g sine square theta into 4 square. So just make a difference of these two. So if I divide these two equation equation 3 from 2, I will get h naught is equal to half g sine square theta into 12 square minus 4 square. Let it be like this, and we'll come back to this equation later. And now the thing that was asked, how long after they were released will they be at closest to each other? So now the relative motion part. So suppose this is a ball 1 and this is ball 2. Initial relative velocity 0 because both were released from the same horizontal position. So looking from ground, with respect to ground, in the ground frame, the magnitude of their acceleration is same. This is theta, this is theta. So acceleration of ball 1 is along this direction, this acceleration is a, and acceleration of ball 2 is along this direction, and this acceleration is also a in magnitude, and both magnitude has a is equal to g sine theta, and u relative is 0. So the best approach would be to stop the one ball and from that frame look the other ball. So I am stopping one ball, I am watching the ball 2 in the frame of ball 1. So now once again, in the frame of ball 1, this is ball 1. The ball 2, if we see the ball 2, this is a ball 2, it has its own acceleration a, and this a will give its acceleration in the opposite direction like this, like this. So their relative acceleration would be, so the vector sum of these two, so the relative acceleration would be clearly along this direction. That is going to be the a relative, and this is theta, this is theta, so this is theta and this is theta. You can see clearly a relative is equal to 2a cos theta, and u relative was 0 because both were initially at rest. So with respect to 1, the path of 2 would be a straight line along this direction, that is the path. So this is the path of 2 with respect to 1. So this minimum separation would be here. This is the minimum separation. This is the minimum separation, and that thing I had assumed to be h naught. And suppose, let me name this, suppose this point is A, this is B, and this is C. So this minimum separation will be obtained after traveling a distance BC. So how much is BC? BC you can see is h naught cot theta, and the particle 2 start from the 0 relative velocity with respect to it with the relative acceleration a relative. So you can write, if the time taken is say tau, so that BC is equal to half a relative into tau square. Just put the value. This is h naught cot theta, half a relative is a 2a cos theta into t square. Again, let me go to next page. H naught cot theta is equal to half into 2a cos theta into time square, that is tau square, h naught. You can write the value of h naught from here. The h naught is half g sine square theta, 12 square minus 4 square. Cot theta is cos theta by sine theta. This 2 and 2 will get cancelled, and a was g sine theta. A was g sine theta, and then there is a cos theta and tau square. You see, this sine square theta by sine theta is just 1 sine theta and cos theta, so that thing, this thing will all get cancelled, g will get cancelled. So tau square would be simply 12 square minus 4 square by 2. So that is how much? That is 144 minus 16 divided by 2. You will get that tau would be 8 seconds. So we've got option 2 as a correct option. Thank you.